Capabilities doing Snell certifications here, or not certifications, but basically making sure it will pass the Snell certification ongoing and before we send it to Snell for certification. We can do DOT testing, we can do ECE testing, we can do ASTM, which is a multi-sport helmet for snowboarding or bicycling, and we can also do CPSC testing here. But we're going to show you a Snell test, a typical Snell test. The first drop, we're going to drop it from is 3 meters high. You can see we've got a cutout in the ceiling to make sure we can hit it from the heights necessary. And then we'll go ahead and hit it a second time, which is part of the Snell protocol, and that's from 2.2 meters. So Ken Baker, our product developer here, is going to show you guys how it's done.
All right.
Now this is also done back at your factory. They'll test there?
Correct. We to make things a little bit quicker and sometimes speed things up, we can have them verify it before they send it to us, and then we'll double verify it.
Kind of validate it back here.
Correct. And we also have the capabilities of getting different density EPS liners shipped here, the helmet's not assembled, and basically building up different configurations and testing them here to prove out which density matches up with our shell best for the best performance before we get to Snell or DOT.
All right, Ken's got that locked in up top, and this is for the first drop, 3 meters.
3 meters on a flat anvil, and we're just doing the ambient condition right now.
You'll notice he put a little white dot on here, and that's just basically, so once the helmet falls and hits this, we know exactly where the helmet was impacted, and we can hit it a second time in that same spot.
All right, you ready?
Let's do it.
So it's the first impact.
First impact. And then what we're able to do now is I got to reposition the gate, bring it down to 2.2.
And then what happens over here on the other side? There's a screen, and it's going to measure the actual force, right?
The impact force.
And the time.
Correct.
The event, kind of lasted, right? We're not going to talk about any of that stuff because the reality is those are kind of company secrets, and they should be kept that way.
Yeah, we strive to actually make the helmet pass with a huge margin of error, so that way in certification we know we're going to pass. Plus, the whole goal is to make the helmet is basically absorb the impact
as much as
best as
possible.
possible.
Yeah.
I mean, if we can make it that much better, we will. And our whole goal is to not only meet the standard, but actually completely blow it out of the water. So, so that's what we're doing here, and that's part of the reason we have this test lab here, is ongoing testing and making the helmets better.
And you guys test so many helmets that you had to get a helmet crusher.
Yep, we've got a helmet crusher. Part of the reasons we do test a lot of helmets, and we're throwing away a lot of helmets, and you always have the fear of someone dumpster diving or grabbing stuff out of our dumpster. So we make sure we cut the straps out, crush them to the point of they're completely flat. We got a crusher, and we throw away a lot of helmets.
That's 2% of everything you make is a
Yeah.
ton.
It's not uncommon to test tens of thousands of helmets in a year just in batch testing.
Amazing. All right, go
All right,
ahead.
we're doing hit number 2.
So that's impact number 2. And the whole goal here when you're testing these helmets or developing these helmets is the impact liner has got to be able to absorb the impact the first time and not completely crush out. So on the second hit, you still have some properties, impact absorption properties.
And that is one of the areas where the Snell standard kind of veers from the ECE. They're going to look for 1 hit.
Correct, and we're doing 2 hits.
Okay.
And the Snell standard does the ambient. They do a hot temperature, so we have an oven over here. We'll heat the helmet up and test it and see what the results we get from that. And then we also have a cold, and we also test the helmet in wet conditions.
Okay. Now the next one is going to be the spike test, the penetration test.
Penetration test.
Now, with Snell, do you know exactly where they're going to hit it? I mean, do they pretty much like send you a chart that says we're going to hit it here, we're going to hit it here, and we're going to hit it here?
Random. They decide. I mean, it has to be within the test line, which they will have drawn on here on an official certification, but it has to be above the test line. But no, they can go right in event. They can go right dead center on the crown. I mean.
So I would imagine then when you guys are going through the development process, you're going to, okay, I'm Mr. Snell, and you're going to think where is going to be the weakest spot on this helmet, and that's where you're going to focus on hitting it.
Typically, yeah.
Okay.
like we know that there's some draft back here, so we know Snell may attack this because it appears that, oh, the helmet's probably getting thinner in this area, so we have to ensure that will still withstand the test.
The whole point here is to drop the penetrator and not penetrate through the helmet into the head form. So you'll notice we had some foil and some tape on the head form, and that way we can tell if that's penetrated and compromised the head form down below.
Alright, set up there. Alright, you guys ready to see this?
We're ready.
3 meters. That is, let's see how she did.
You can take a feel, that thing is really
Yeah.
heavy.
Yeah, there's definitely some weight to that, there's
Oh,
no
yeah.
doubt. And there is no mark.
No mark, that would be a pass.
Typically in a Snell helmet, when we're about to go to certification, we know it's going to pass impacts. We've never had a Snell helmet fail this portion. Unless we're in development, we're trying to make the vents really, really big. That's usually where we see failures. But by the time we get it to pass this test, we usually know it's going to pass this test.
Okay, well, that's good. You definitely don't want to, have production runs ready to go and then you send it off, hey, let's get it tested, and then it fails.
Right.
That'd be a really expensive
Tooling is
mistake.
very expensive, and to retool stuff, and that's one of the reasons that helps pay for this lab and our prototyping facility is basically saving money on retooling things. We know when we go to the testing it's going to pass because we've done our homework prior.
That's the way it should be. There's another test that is the retention test, right?
Yeah, this is the test, the retention straps, the webbing that's used to secure the helmet. And the goal here is to test it and stretch out the strap. And you want only a certain amount of stretch or elongation. So they're testing to make sure that webbing does not elongate more than it's supposed to. It also ensures the attachment points do not pull away from the helmet or pull through the fiberglass or the Kevlar or the carbon, whatever composite we are using.
These attachment points are kind of unique for Bell, aren't they?
Correct. We basically historically mount our attachment points in the perfect spot for roll-off, and we found with our auto racing and years of motorcycle helmet production that this is actually the best spot for roll-off testing, so the helmet does not roll off your head.
What is
testing.
roll-off?
They take a device and grab the back of the helmet and a weight. It's
Pull
a
it
slip
off.
weight, and they drop a specific amount of weight and try to pull the helmet off the back of the head. And we, when developing helmets, we always try to see if we can somehow hide these, but this is specifically the best spot for them. And we're not really, like I said, safety is the first and foremost concern. And if we can get something to look good while making it safe, we'll do that as well.
It's just bonus, but I mean, the number one thing is the helmet, for God's sake.
Correct.
Let's worry about protecting the wearer first,
Yep.
and then bring all the other stuff in after. Okay, we're going to go ahead and we're going to detail the roll-off test now. They've set up the test rig, they've got the helmet on there. This is the mechanism they use to test that. And what I want to mention is, as we've shown you, many helmet manufacturers are going to put the attachment point for the strap kind of under the base plate, so it's hidden, so you don't see it cosmetically on the outside of the helmet. Bell has done that in testing, and you guys have been able to get it to pass.
Yeah, and improve the performance. I mean, there are plenty of helmets out there that pass where it's underneath, but you'll notice on ours that you don't get a lot of pivot out of it. It stays in a pretty good position.
But at the end of the day, this was the most effective spot
Correct.
from a safety
Yes.
perspective, so that's where you left it. We're just going to go ahead and just show you how they do this.
Right, so the helmet's on there with the correct head form.
Kind of a simple slide hammer.
Yeah.
So there you go. There is the roll-off test, and we've just given you a brief description as to why Bell has chosen to place the anchor point right here.